Hello guys, welcome back to Chow Chow 2025. Are you looking for the fastest, simplest way to generate high-quality image to video using WAN 2.1 in ComfyUI? You don't need dozens of custom nodes. Today, I'll show you a clean, beginner-friendly workflow using almost entirely ComfyUI's core components, focused on the WAN 2.1 14B Lightning model for speed, optimal settings, and the final results. To maximize speed, we use the Lightning model. This workflow requires 4 key files. For image to video model, you have two options: 480p model and 720p model. Go to Civitai, link in description. Download the WAN 2.1 14B image to video model that you want. Both has big size, it will take a moment. Whether 480p or 720p that you choose, save it in models/diffusion models. ClipVision model, download the ClipVision h.safetensors in civitai.com, link in video description. Save it in models/ClipVision. VAE model, download the WAN 2.1 VAE BF16 from Hugging Face, link in video description. Save it in models/VAE. Clip text encoders, download the UMT5XXL encode FP8 model, save it in models/text encoders. Also make sure you update to your latest ComfyUI version. Old ComfyUI version might not able to use WAN natively. Or if you want to be safe, just try following the step first, and if is error, you could always update your Comfy later. But here is how to update your ComfyUI installation. Go to Manager, click Update ComfyUI. After that, click Restart. The only external node required is the Video Combine node, which comes from the Video Helper suite. Open the ComfyUI Manager, click Install Custom Nodes and search for Video Helper suite. Click Install and Restart when prompted. Now let's build the workflow with optimal speed settings. Add a load diffusion model node, select your I2V model and set the weight type to FP8 for efficiency. In this example, I use 480p first. Add a load clip node. Select the UMT6 model, set type to WAN and leave the device as default. Add a load VAE node and select the WAN VAE. Add a load ClipVision node and select the ClipVision H. Add a model sampling SD3 node, connect the load diffusion model output here. Set its shift to 5. Add 2 clip text encode nodes for your positive and negative prompts. Connect the load clip output to both. Add a load image node and select the picture that you want to animate. Add a ClipVision encode node and select your crop setting. Connect the load ClipVision output to its ClipVision input. Connect the load image output to its image input. Add WAN image to video node. Connect the positive prompt to its positive input. Connect the negative prompt to its negative input. Connect load VAE into its VAE input. Connect ClipVision encode output into its ClipVision output input. And lastly, connect your start image into its start image input. The start image can be the same or different with the reference image. For length, we leave it at 81 since is the number that WAN used to train the model, but you could change it if you want. Add a K sampler node, connect model sampling SD3 output to its model input. Connect WAN image to video positive, negative and latent output to its positive, negative and latent input. This is where we maximize speed, set steps to 4, CFG to 1 and the sampler name to LCM. For the positive prompt, I'm using, a woman is smiling and then turn around. Use a strong negative prompt to eliminate common artifacts, show the negative prompt on screen. Add a VAE decode node to convert the latent space to pixels. Connect the K sampler output and the load VAE output here. Also, before we execute, make sure the width and height of the image is adjusted in WAN image to video. Add the Video Combine node from the Video Helper suite. Set the frame rate to 24 or 25 and select your desired format. Connect the VAE decode output to the Video Combine's images input. Now let's run it. Using this highly optimized workflow on my RTX 4060 Ti 16GB RAM, a typical 81 frame generation takes between 16 to 25 minutes including loading the model. This is great performance for a high-quality 14B model. If you need even more speed, you can integrate Triton, but that's a topic for another video. Once you load the model, it only take about 200 to 300 seconds to generate the video, like this example. Now here a bunch of 480p video result and their prompt. The first frame is the original image, so no need for me to show the difference. Okay, the next part we will try the 720p model. I will restart my ComfyUI so it load all the model again so we can count the first generation time. Remember to change the video size into 720 and 1280. It take about 35 minutes to do first generation. Now let's see how fast it is to generate the next video. The next generation is taking 12 to 14 minutes for 720p model. Here a bunch of other example while I am saying goodbye. You now have a simple, fast and stable WAN 2.1 image-to-video workflow. Thank you for watching. Don't forget to like, share and comment. See you again on the next episode. Please subscribe and have a nice day.